For our group presentation, we were assigned to talk about integration and system testing and why it's important in our discipline of software design. So basically, it falls into two different schools of thought or two different types of testing. First, you have system testing, which is basically just testing the overall product. So you'd be testing the usability of it, the performance, the stress load, security. Generally, you're just trying to simulate real life scenarios and apply them to your product. So all the testing is done at generally a pretty high level. So an example of this could be if you were creating an online store. So you'd want to test to make sure that the usability is good, so the user can add things to their cart pretty easily and it's all very seamless. You want to test the performance to make sure that your pages don't hang or the load times are super long. You want to test the stress load to make sure you can handle the number of customers that are coming into your website. And of course, security would be a big deal on something like this because you want to make sure that your customers' credit cards aren't being stolen or one of your customers is being impersonated by somebody else, things like that. Now, taking a look at the other side, which would be integration testing, this is where you'd be testing how the different pieces of your program interfaces with itself. So you'd be testing things like your APIs to make sure that they function well with one another. You'd be testing to make sure that all your internal modules are playing nicely with each other. So going back to our online store example, you could say you'd want to test to make sure that your database API is working correctly in fetching user data and stored data. Or maybe your API that goes out and gets credit card numbers and processes payments is functioning successfully as well. So these are basically what system testing and integration testing are.
Hi, my name's Matt Pickett. I'm going to talk about some of the upsides to integration and system testing. One of the advantages of using integration testing is that it increases the ability to track where the bugs are occurring. Since each module is being individually tested and having a high focus on specific modules, that makes the test easy to locate where the bugs are occurring. And that in return makes finding the bugs easier and makes the debugging process faster. Another benefit or upside is that it allows the engineers to see what data is being passed from the models and from the modules. This is important because with multiple engineers or developers splitting up writing code or focusing on specific modules, it ensures that the correct data is being transferred, and that gives a strong sense of data integrity. Some of the upsides for system testing is that it allows engineers to see how the product will run when all modules are combined in a real live scenario. So during the development process, the code is split up and a lot of different developers work on specific parts of the software, but when it all gets put together, it allows the engineers to see the entire process. This helps give a good understanding if the product is meeting requirements for the client. And it allows an ability to check to see if everything is up to date and meeting requirements with the software spec. One of the other benefits of system testing is that it allows new bugs to come to light once all modules are put together. While if you're focusing on integration testing and just one specific module or function, you might not have any bugs, but when all of them are put together, in system testing that might bring new bugs and in return give a chance to have a software product that runs much better.
Downsides to integration and system testing. We have Big Bang integration testing. In Big Bang integration testing, all components or modules are integrated simultaneously, after which everything is tested as a whole. So the major disadvantage is that in general, it is time consuming and difficult to trace the cause of failures because of late integration. We also have top-down integration testing. This testing takes place from the top to bottom, following the control flow or architectural structure. So it starts from the graphical user interface and goes down to the subsystem. The main disadvantage of this is basic functionality is tested at the end of the development cycle. We also have the bottom-up integration testing, and this testing takes place from the bottom of the control flow upwards. So it starts from the subsystem up to the graphical user interface, and components or systems are substituted by drivers. Some of the disadvantages are we can't catch the key interface defects until the end of the development lifecycle, and it's also required to create the test drivers for modules at all levels except for the top control. So it adds some extra programming. Sandwich integration testing is the last one, and it's a combination of both top-down and bottom-up approaches. It is also known as hybrid integration testing or mixed integration testing. In sandwich integration testing, the system is considered to be made up of 3 different layers. A layer in the middle, which will be the target of the testing itself, a layer above the target layer, and a layer below the target layer, and then testing begins from the outer layer and converges at the middle layer. The disadvantage to this one is that extensive testing of the subsystems is not performed before the integration.
It is recommended to use integration system testing after unit testing. Unit testing is the smaller part text testing. Integration combines those smaller modules together for testing, and then the system testing tests the overall system as a whole. So after units are created and tested by themselves, we recommend you use integration and system testing. Integration testing is particularly important for large projects with lots of modules that have lots of data transfer going on. This helps see unforeseen problems, if there are errors between module communication, and to catch any faults with module combinations. After the module combinations have been checked out, system testing can test the overall system. Even if you have a smaller project, system testing is still applicable as you test the overall system to make sure that it meets requirements and turned out how you wanted it to turn out. Both of these methods of integration and system testing are very effective, and we recommend that you use them for nearly, if not all, of your software projects. Thank you for watching our presentation. We hope you enjoyed it.